Welcome to Assistant and Android for Cars session. Hi, I'm Madhukar Srivastava, and I'm a product manager on the Google Assistant team. With me today is Jessica, who is a developer relations engineer. Thanks for joining us in this session, where you'll learn how Google Assistant works with Android for Cars. Despite changes in driving behaviors in the last 2 years, our users still spend a lot of time in their car, with over 1 billion cars on the road. Google Assistant wants to be present and be helpful where our users are. In 2018, Google Assistant was integrated into Android Auto, allowing users to use their voice in their car to get things done. Since then, user adoption of voice assistants in car has steadily increased over the last few years, according to a recent consumer adoption report. Also noted in that report is that users are evaluating voice support when purchasing cars. 35% of Google Assistant users cite the feature as a car purchase requirement or a significant consideration. With the flexibility of Android, and thanks to developers like you, we've been able to bring the helpfulness of Google Assistant tailored for every drive, regardless of the type of car. Whether a user has an older car, is looking to stay connected in the current car, or is in the market for a new car, we have 3 main product experiences to help users on their drive. First is Assistant Driving Mode, which lives on the phone screen and allows drivers to get things done on their phone with the voice without leaving Google Maps. Second is Android Auto, which allows you to connect your phone to the car display. The third product experience is Android Automotive OS with Google built in, where Android runs directly on the car, powering the infotainment system and giving drivers access to their favorite apps directly on the car display without the need for a phone. We'll focus on the latter 2 experiences in today's session and demonstrate how Google Assistant enhances the Android for Cars experience with voicified apps. We are very excited about voicifying apps for Android for Cars, as it allows users to access your app's content in a safe and optimized manner while driving. Voice is a natural fit in the car, as it helps users get things done in a simple, seamless, and hands-free way, so they can have their hands on the wheel and focus on the road while accessing your apps through voice and making their journeys delightful and productive. App Actions is the easiest way to integrate your Android apps with Google Assistant, letting your app join in fulfilling millions of Assistant user queries. It lets your users jump right to the most interesting and useful points in your app with simple voice commands. Assistant does this by understanding what capabilities apps support and which apps can best fulfill users' requests. Today, we'll start off with an overview of building for Android for Cars and of App Actions. Then we'll do a deep dive on how Google Assistant's App Actions can enable voice control for Android Auto apps. Let's do a quick overview of building Android for Cars. We recognize that it's not easy to develop apps for cars, given the various screen form factors and input methods, on top of the overarching focus on driver safety. There's really a lot to consider, and our developer tools address these challenges. Our goal is to simplify the process of developing apps for cars. That's why we introduced the Car App Library. This allows you to write your code once and make your apps available across both Android Auto and Android Automotive OS. The user interface is designed with driver safety in mind, which in turn helps you build apps that are safer without needing to become an expert on driver safety. And voice is an important form of input in cars, so apps built with the Car App Library enable you to have seamless integrations with voice assistants. Unlike phones and tablets, where you get flexible control over an app using the touchscreen, in cars, we are providing you with predefined templates that were carefully built with driver safety considerations. Our approach is to expose relevant templates to you according to your app's category, and over time, build a cohesive library that allows for even more customization. We have started that journey for the Car App Library with navigation, parking, and charging apps. Let's walk through the architecture for a car app. When your app is launched in the car, a host application running on either Android Auto or Automotive OS will connect to a car app service that you will extend. In your car app service, you will override onCreate session which returns a session instance corresponding to the current connection to the host. The session is responsible for returning the screen instance to use the first time the app is started by overriding onCreateScreen. Then each of your screen classes will implement onGetTemplate, which returns a template object representing the state of the UI to display in the car screen. The template will be fed back to the host application, which will render the UI for you. With Android Auto, you'll find the same look and feel across all cars running Android Auto. With Android Automotive OS, it's a bit different. You'll find the rendered UI influenced by car manufacturers' customizations. So your app will feel like it belongs in that specific car without any extra effort on your part. We're also expanding the charging and parking category to include more point-of-interest apps to help users find locations of places they want to go. The Car App Library allows you to write your code once and make your app available across both Android Auto and Android Automotive OS. Let's go over to Jessica to learn how Android apps can use Assistant via App Actions and how they integrate with the Car App Library.
Thanks, Madhukar. Hi, I'm Jessica. Let's do a quick overview of App Actions. App Actions is how developers integrate Google Assistant with their Android apps. With App Actions, users can jump into the most interesting and useful points in your app with simple voice commands. Let's think about this in two main steps, required for users to access your app's features through voice commands to Assistant. First, you need to process the user's spoken input and understand their request. Second, we need to fulfill the user's request. To understand a user's request, Assistant has identified and supports over 60 intents, which we call built-in intents, or BIIs for short. These BIIs are also arranged by several categories. Assistant does what is called in the natural language world intent matching between the user's speech to the BII. Intent matching loosely means identifying several speech patterns for a particular functionality or intention of the speaker. Let's walk through the user's experience and see who does what. So we have the user, Assistant, and your app. When the user says, "Hey Google, find charging near SFO on example app," Google Assistant will process the user's input using natural language understanding, or NLU for short. Assistant will intent match and pull parameters supported by that intent. BIIs understand that there are different kinds of charging stations that someone could ask for, like address or name of a location. This information is added as a field of the BII, so the app can provide exactly what the user wants. Here, the Get Charging Station BII is matched, and the location, SFO, is pulled from the user's input and set to the corresponding coordinates. The app is triggered with this data and opens the app to a map or a list of charging station options. Since Assistant takes care of all the NLU, all you need to do is select which BIIs your app will support and how you want to fulfill these user requests. You can use Android intents or deep links to launch your app as fulfillment. Here, let's take a look at how App Actions work across Android for cars. On auto surfaces, App Actions integration works both for Android Auto and Android Automotive OS. The Auto app needs to be built with the Car App Library from Android for cars. At this time, App Actions on Auto supports BIIs that are relevant to on-the-go use cases, parking and charging. On screen are a couple BIIs with matching example queries. Let's take a look at how those BIIs work with a partner, ChargePoint. ChargePoint allows users to find charging stations on the go. They also have two demos for the two different user experiences. Starting with the Android Auto user experience, where the user says, "Hey Google, find charging stations near 1600 Amphitheater Parkway with ChargePoint." The app launches with a map and a list of charging stations. Moving to the Android Automotive OS, users get a very similar experience, but with the flavor of the car manufacturer customizations. This example is a user saying, "Hey Google, find charging stations in Mountain View with ChargePoint." By using Car App Library and App Actions, you build your app once and it provides a great user experience on both Android Auto and Android Automotive OS. Let's walk through how to integrate App Actions into a car app. Here's an example where we need to first declare support of App Actions in the main activity. You could do so by adding shortcuts metadata in your Android manifest file. Then we will need to declare that our car app supports deep links. You could do so by creating an intent filter for deep links in the car app activity. Then we need to specify the built-in intents that we are supporting. We'll need to add capabilities to our shortcut.xml file. Capabilities are expressions of the relevant feature of an app, and it contains the built-in intent and its fulfillment. Here we have a capability that is tethered to the getCharging BII and a list of related parameters. The intent tag contains all the information for the fulfillment. Let's walk through it. Starting with the deep link, here is an example of one with the supported parameters. There are several supported parameters, like type, for situations where the user might say fast or free charging. Next is name, which covers situations where a user might say, find parking near Google headquarters. After that, address, which covers situations if the user provides an address like 1600 Amphitheater Parkway, Mountain View. Finally, for situations where the user provides the latitude and longitude, or Google can pinpoint to the latitude and longitude, you can capture that too. When the getCharging station BI gets matched, the parameter and values are appended to the deep link and passed to the fulfillment methods. Next, let's specify the fulfillment implementation in our car session. If a session is not created, an intent to start the app will create the session and pass the intent in the onCreateScreen method. If a session is already created in memory, the session will reuse the same intent and pass the intent to the onNewIntent method. Here is an example of how Android apps get the value of the getCharging station deep link when creating a session. The deep link contains all the parameters matched by the BII so the app can act on what the user said. Similarly, when a session is already created, the deep link will be passed onto the onNewIntent with all the parameters matched by the BII. Here's an example of how the Android app gets the value of a getCharging station deep link. Please note that the car app library currently only supports deep link fulfillment and that we're working on Android intent support. Be sure to check out the docs to find out when it gets supported. Let's now add voice support to your users by implementing app actions in the car app. Back to Madhukar to wrap this up.
Thanks, Jessica. Let's do a quick recap. Assistant surfaces content for Android for car apps and Android mobile apps across many surfaces like Auto. Android developers can extend their Android apps to Assistant with app actions. App actions has built-in intents, or BIIs, for apps using the car app library, like Get Parking Facility and Get Charging Station, to provide voice support in the car. These BIIs allow developers to leverage Assistant's natural language understanding and provide a safe way for the users to get the functionality they want. We are looking forward to adding more BIIs in the future. To get started, check out these links for more information about Android for cars and app actions. On behalf of Jessica and me, thank you for joining us today, and we are excited for the road ahead with you.